Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I am going to teach you some algebra right now. This is lesson 2.2, solving inequalities by addition or subtraction. So we looked at inequalities on the previous lesson, and like I said then, these are the cousins of equations, so a lot of the properties are the same. So this time we'll look at the addition and subtraction properties of inequalities. And it's essentially this. For the addition property, all it really says is if I have a true inequality, like negative 3 is less than 2, that's a true inequality. If I add the same amount to both sides, I will end up with a true inequality. Over on this example over here, negative 3 is greater than or equal to negative 10. That's a true statement. If I add the same amount, in this case 3, to both sides, I will end up with a true inequality. I will always have a true inequality. If I start with a true inequality, add the same amount to both sides, I will end up with a true inequality. That's what we're going to use to solve these inequalities, just like equations. Okay. X minus 6 is greater than or equal to negative 10, then graph the solution. All right, so what I'm going to do here, I'm going to add 6 to both sides, just like I would have done if this was a equation. Negative 6 plus 6 cancels out because that becomes a plus 0. So x is greater than or equal to negative 4. Then I'm going to graph it. Here's my boundary, negative 4. It's equal to negative 4, so solid dot. And it is greater than negative 4, so to the right of the boundary. Easily done. Okay, if you need to see that again, just back the video up and watch it again. Let's take a look at another, I think we're looking at subtraction right now. Subtraction. Very similar to addition in that if I start with a true inequality, like negative 3 is less than or equal to 1, and I subtract the same amount, in this case 5, from both sides, I will end up with another true inequality. Negative 8 is less than or equal to negative 4. And same thing over here for the greater thans. 7 is greater than negative 20. If I subtract the same amount, in this case 7, from both sides, I will end up with another true inequality. 0 is greater than negative 27. Okay, that's the idea. Subtracting the same number from each side of a true inequality will produce another true inequality. Okay, so let's take a look at some practice problems here. Y plus 8 is less than or equal to 5. If I subtract 8 from both sides, I get y is less than or equal to negative 3. And I'm going to graph that one on the first line here. This is an A. Sorry. This is an A. Okay, my boundary is negative 3, and it's y is equal to negative 3, so I'm going to use a closed-in dot there. And then y is less than negative 3, so I want the numbers that are to the left of negative 3. Oops. Sorry, my thing went out of kilter there. Okay. And then for b, even with the decimals, negative 8 is less than 1.4 plus m. If I subtract 1.4 from both sides, I'll have negative 9.4 is less than m, which means m is greater than negative 9.4. My boundary is negative 9.4, so I'm down here. And it's an open circle because we're not equal to negative 9.4, just that's our boundary, but not equal to it. And I want m is greater than, so I'm going to actually be going to the right at this point. There's my graph for B. A little word problem here. A circuit overloads at 1800 watts of electricity. You plug a microwave oven in that uses 1100 watts of electricity into the circuit. A, write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. Okay, so the left side is going to be what I'm using. The right side is going to be kind of like my boundary. So 1100, that's my microwave, plus, I'll use X for this. This has to be, oh, and we'll put the boundary over here so we can talk about it. The amount I'm using has to be what? Greater than or less than my overloading limit. This has to be less than. Or I'm imagining not equal to because it overloads at 1800. So if it's equal to, it will overload. So this has to be just less than 1800. So there's A. This is the, at least this is the, that's not A, that's an at. A. There's the right. Now we'll solve. So if I subtract 1100 from both sides, X has to be less than 700 watts. Okay, so there's right and solve. Now B, in addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time without overloading the circuit? Well, we need appliances that are less than 700 watts. So it could be the clock radio, it could be the blender, and it can be the toaster. And let me see, can we do all these at the same time? 350 and 80 would be 430. So sure, we can plug all those at the same time with the microwave or individually with the microwave and not overload the circuit. Hot plate, though, at 1200 will overload the circuit along with the microwave. And that's it for now. That was a short and quick one because, again, these are so related to equations. I don't have to go into too much detail. We just have to make sure that we're graphing properly, and that when we translate word problems into inequalities, we're doing that properly. Okay, thanks a lot. That's it for now. Have a great rest of your day, and I'll see you in class next time. Bye-bye.